Next, we're going to learn the permutation formula. The permutation formula allows you to determine the number of permutations or arrangements given specific parameters. The notation P of n choose R means the number of possible permutation of n things taken R at a time, and the algebraic notation is P of n choose R equals n factorial over n minus R factorial. Some books and some calculators use the notation NPR like this, where there's an n is a subscript, a small and low, and some write it like this with a subscript of n comma r. So if you ever see any of those, these are all the same ones. Our book uses this one, so that's why I chose to use that one in our notes. But your calculator might have a different notation, or another book, if you ever use another book, might have another notation, and that's okay. For our first example, suppose there are 8 swimmers in the final race at a swim meet. First place will get a gold medal, second place will get a silver medal, and third place will get bronze. How many different ways could the swimmers medal? So we could use a multiplication principle on this one, but we're trying to use our formula. So n and r. N is the total number of things that we can choose from. How many swimmers can we choose from? Well, 8. And how many places are going to get a medal? Well, 3. Does order matter? Yeah, order matters quite a bit. Remember those 2 conditions that we were talking about? The first condition is that no item can be used more than once. No swimmer is going to come in both first and third. That doesn't make any sense, okay? And then the next condition is that order matters. Does order matter? Yes. Order matters in a race considerably. So we are going to use P of 8 choose 3 in my formula. So we have 8 factorial over 8 minus 3 factorial. So 8 factorial on the top and 5 factorial on the bottom. Now we taught you how to deal with this. 8 times 7 times 6 times stop at 5 factorial. The reason I want to stop at 5 factorial is because the numerator and the denominator 5 factorial can divide out nicely. And really all you have is 9 times 8 times 7, which is 336 different ways the 8 swimmers could come in first, second, and third. Now we're not even talking about how the rest of the people place. We're just talking about first, second, and third because we're only choosing those. Now your calculator can do a lot of this for you. If you get your calculator out, you could type in 8 factorial divided by 5 factorial, and that gives you 336. So some calculators have a probability button. So if you go into my probability menu here, or have a NPR, and I can use that button to solve my problem. Now we were doing 8 choose 3. So going back to your home screen, if you type 8 first and then use the probability button and then use 3, you can get the same 336. Now your calculator might be different. Go ahead and read the manual and see if you can't figure out how to get your probability button to work so that you don't have to use the formula every time. For today's lessons, probably not a big deal to use the formula, but in the next few lessons you're going to want to have a permutation button handy. Our next example, we have a corporation that has 7 different members on its board of directors. How many different ways can it elect a president, a vice president, a secretary, and a treasurer? Because each of these positions is different, this means that order matters. So like if the first person we pick is president and the second person we pick is vice president, and so on and so forth, order matters. So we have N equaling 7 different members on the board. R is 4 different positions: president, vice president, secretary, and treasurer. So we're going to do probability of 7 choose 4. So that's 7 factorial over 7 minus 4 factorial, which is 7 factorial over 3 factorial. If you want to do this longhand, you get 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. And the 3 factorial and 3 factorial divide out. And then when you get out your calculator, we can type 7 times 6 times 5 times 4 in the calculator and get 840. The other way we can do that in our calculator is we have type 7 if you have a probability key, and then 7 choose 4, and that's still 840. So either way you want to do it is fine, but having a probability button is going to be helpful in the next couple lessons. But you can always go back and use the formula. Now suppose you were asked to list in order of preference the 3 best movies you have seen this year. If you saw 20 movies during the year, how many different ways can the 3 best be chosen and ranked? Again, does order matter? Yeah, it does. Okay, 3 top best, okay? And ranked. The whole idea, because it's and ranked, that means the order matters. And additionally, you can't choose the same movie twice. So we have n items, 20 total movies. We're choosing the top 3, and so we're going to take the probability of 20 choose 3, which is 20 factorial over 20 minus 3 factorial. So that's 20 factorial over 17 factorial. If you're doing this longhand, 20 times 19 times 18 times 17 factorial, stop at 17 factorial, because that's going to divide out in the denominator, and you just have 20 times 19 times 18, which gets us 6,840. You could also type in your calculator 20 permutation 3, and you'll still get the same answer. Sometimes we need to find permutations when the items that we're selecting from aren't distinguishable from one another. So if we have n objects in a permutation that are not distinguishable, then the number of distinguishable permutations is found by the formula n factorial over n1 factorial and times n2 factorial times dot 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 times n sub r factorial for n1 of type 1 and n2 of type 2 and so forth for r different types. So if you have something that's not distinguishable and you're pulling from that group of items, you need to keep dividing out by that n factorial. So we have a few examples here. The first one, how many ways can the letters A, B, and C be arranged? Now, note that A, B, and C are all different and unique and distinguishable. I can tell that an A is different from a B, which is different from a C. So this does not classify as the permutation that are not distinguishable. This is just a normal permutation. So I have 3 items, A, B, and C, and I'm choosing all 3 of them. So I'm looking for a permutation of 3 choose 3, which is going to be 3 factorial over 3 minus 3 factorial, which is 3 times 2 times 1 over 0 factorial. Remember, 0 factorial is just 1. So that gives us 3 times 2 is 6 times 1 is 6, divided by 1 is still 6. So we have 6 different ways that we can arrange the letters A, B, and C, because they are all unique. But next I'm asked how many ways can the letters in the word Mississippi be arranged. Notice that the word Mississippi has a lot of repeating letters. Unlike A, B, and C, Mississippi has a lot of letters that are indistinguishable from each other. So I have Mississippi, which has 11 letters in it. I have 1 copy of M. For I have 1, 2, 3. I have 4 I's, 4 S's, and 2 P's. And that adds up to my total of 11 letters. So if I'm trying to find the permutation here, I'm going to start with n equals 11, 11 factorial over, the m's are 1 factorial. For the i's, I'm going to be multiplying by 4 factorial, times 4 factorials for the s's, times 2 factorials for the p's. So when I take out my calculator and multiply all these, I will get the number of ways that the word Mississippi can be arranged. I had to divide out by the 1 factorial, 4 factorial, 4 factorial, and 2 factorial because of the repeated letters. So I have 11 factorial, so I'm going to use the permutation menu to find the factorial divided by, I'm going to use parentheses because I need to include all of the denominator together, 1 factorial times 4 factorial times another 4 factorial, and then times 2 factorial. Then I'm going to close my parentheses. So this gets me 34,650. Different ways that we can arrange the letters in the word Mississippi. Next, we have a student who buys 3 cherry yogurts, 2 raspberry yogurts, and 2 blueberry yogurts. She puts them in her dorm room refrigerator to eat one a day for the next week. Assuming that the yogurts were of the same flavor are indistinguishable, how many ways can she select yogurt to eat for the next week? So we have n equals 7 different yogurts. But because the 3 cherry yogurts, she can't tell the difference between them. We have N1 is 3, N2 for raspberry is 2, and N3 for blueberry is 2. When I use my formula, I have 7 factorial over 3 factorial times 2 factorial times 2 factorial. I know that because there are multiple things in the denominator, I need to put parentheses around that denominator. So I type 7, use my probability menu to select the factorial button, divided by parentheses 3 factorial times 2 factorial times another 2 factorial. Now I'm going to close my parentheses, and that gets me 210. So there's 210 different ways that she could select her yogurt for each of the days of the next week. And this concludes our lesson on multiplication principle and permutations.